The sun is the source of all our energy. Without it, nothing lives or moves on this planet. The sun's heat lifts water from the sea, and here in Norway it falls on the barren mountains where it accumulates to form vast reservoirs of power. Beneath the bed of the North Sea, the energy released by the sun millions of years ago has been stored as oil and gas. And it's from these two valuable energy sources that the business of Norsk Hydro has grown. Today, our activities are spread across the length and breadth of Norway and in many other countries. We manufacture a diverse spread of energy-based products: oil, gas, fertilizers, plastics, aluminium, magnesium, and a host of byproducts. This is how we use this energy. Today, nearly all of Norway's electricity is generated by water power. We use some of it to produce two light metals. At Karmøy, on Norway's west coast, we smelt aluminium. Aluminium is the commonest metal on Earth and one of the lightest, so it's used in all forms of transport. Aluminium also withstands corrosion from water. Extruded into tubing, its applications include the elements of electric kettles, car radiators, and solar panels to heat a home. Aluminium is also a good electrical conductor, so it's found in computer microprocessors. And at the other extreme, in the large cables that deliver electric power across the country. Electric power is also used to smelt magnesium. We are among the world's leading manufacturers of this versatile metal. Magnesium is the world's lightest structural metal, and as such, its applications are widespread. Here it forms part of an artificial limb. And here, the gearbox casing for a helicopter. It's being used increasingly in the car industry. And in the manufacture of power tools. Our second energy source consists of oil and gas. 20 years ago, in collaboration with some large international oil companies, we were the first Norwegian enterprise to search for them in the North Sea. At the time, it was a pioneering venture, but the intense exploration programs paid off. The first discoveries were the Ekofisk and Frigg fields, and they marked the beginning of Norway's vast petroleum industry. The oil that was found now yields fuels that keep the transport industry on the move. And the gas provides energy for factories and homes all over Europe. The gas is also a raw material for a plastic called polyvinyl chloride, or PVC. One of its many uses is in the manufacture of survival suits for the men who work in the North Sea itself. But our original search there was motivated by the need for an independent source of hydrogen, which is the principal constituent of oil and gas. We need hydrogen together with nitrogen to make fertilizers. For plants can't grow without nitrogen. Although it makes up nearly 80% of the air, its atoms are tied together like this, and this prevents them from being absorbed by plants. So under great heat and pressure, its atoms are separated and joined up with hydrogen to form ammonia, which plants can now use. But this chemical operation needs an edifice of pipes and towers, compressors and pumps, heat exchangers and furnaces. Internal temperature, over 500 degrees Celsius. Internal pressure, 1,000 times that of the atmosphere. To the ammonia that emerges are added phosphorus and potassium, calcium and sulfur, and other substances to provide a wide range of fertilizers that will nourish plants of all kinds, in climates of all kinds. Each year we make enough fertilizer to grow food for 130 million people all over the world. That's more than 30 times the population of Norway. But just as these millions of people need our products, we also need them. For with only 4 million people, Norway on its own could never support an industry of our size. The huge investment required in industrial plant, skilled personnel, and the latest technology, both on land and in the North Sea, can only be supported by a large international market. And this is why nearly 90% of everything we make must be sold outside Norway. Some in markets on the other side of the world. And some in markets which are often the home base of some of our biggest competitors. To overcome these handicaps, we must make use of the latest technology to minimize our costs and energy use and ensure the highest quality in all our products. This magnesium plant, for instance, which we designed and built ourselves, is the most modern and efficient in the world. And so is this aluminium reduction plant, which is based on the latest French technology. Our expertise in the production and casting of magnesium has been incorporated in this car of the future. We're participating in Volvo's experimental lightweight car project. Using the latest materials, this vehicle can reach speeds of 180 kilometers an hour, using just over half the energy needed to run the average car of today. Our second strategy is to manufacture in our export markets. Today, we employ nearly as many people abroad as we do in Norway. In Sweden, we manufacture both fertilizers and PVC to supply the local markets. This factory in northern England helps to supply PVC customers all over the United Kingdom. We also manufacture fertilizers in Britain and supply them to 20% of her thriving agricultural industry. At this factory in Holland, we have invested in one of the largest ammonia plants in the world. It forms a powerful addition to our fertilizer manufacturing capacity, giving us the impetus to compete effectively both in Europe and in one of the world's richest and demanding markets, the USA. On the opposite side of the world is Qatar, in the Arabian Gulf. Here we designed and now supervise the operation of a fertilizer factory that uses locally produced gas. Nearly all the output from this plant is exported to Southeast Asia. Meanwhile, we are already working to secure our energy resources for the future. This is the site of the Oseberg field, 100 kilometers off Norway's west coast. Our job is to bring this rich oil field into production. The oil reservoir lies 2,500 meters beneath the seabed, and the samples of its rocks that they bring to the surface carry much of the vital information that is needed if the full potential of the field is to be exploited. At our research center in Bergen, the latest technology is used to define the properties of the reservoir. Minute fossils, millions of years old, are the labels by which each rock layer is identified. And a computer can display the exact structure of the reservoir at any depth and through any cross-section. The porosity and permeability of the rocks can be measured with great accuracy to discover the rate at which the oil will move through the reservoir when the field is in operation. Once all this data has been assembled, the huge and costly engineering phase will begin. Production wells must be drilled and lined with kilometers of steel casing. From this purpose-built ship, they will lay hundreds of kilometers of pipeline on the seabed to form a network connecting wellheads to production platforms and production platforms to the terminals on shore. And finally, the immense towering structures of concrete and steel, the production platforms themselves, similar to these, which must be assembled, towed out, and set in place on the seabed. When the field comes on stream, it will work like this. The natural pressure of the reservoir will be boosted by the injection of water and gas, and this increased pressure will ensure that the maximum quantity of oil is recovered. But Oseberg lies in comparatively shallow water. Just to the east of it is Troll, the largest gas field yet found in the North Sea, where the seabed is 350 meters deep. A conventional production platform here would have to be 1.5 times as high as the Eiffel Tower, a formidable and costly project. So we have to examine other possibilities. This submarine is part of the School project, one of several ideas now being studied. 100 meters beneath the surface of a sheltered fjord lies the prototype of a seabed production system. The idea behind it is to replace the giant platforms with groups of wells on the seabed, and to control the wells from shore or a distant platform in shallower water. This research is of vital importance, since most of the shallow water fields of the North Sea have now been developed. From now on, the major oil and gas fields will lie in the deeper waters off northern Norway, an area 7 times that of the North Sea. Already, huge quantities of gas have been discovered here. Continued exploration, both in this area and in other parts of the world, is essential to ensure our energy supplies well into the next century. Over the years, our company has been favored by these immense energy resources. To these resources, we have added the human skills, which have built up our business, transforming this raw energy into a diverse range of products that we sell all over the world. This formidable combination has served us well in the past and will enable us to meet the challenges and uncertainties of the future.